So, hello guys, today we will start the exercise number 7, 3D steel frame with masses. Okay, the loads in this exercise, as you may read over here, will include the definition of body forces as centrifugal and angular acceleration forces, and also modal and harmonic analysis. Okay. So once again, I will follow all the steps, all the operations shown here in this book. So now let me switch to robot structure analysis and pick frame 3D design. Okay. Now let me define some cross section. Press here new. Go to the parametric tab and select tubular cross section, and I want it to be called O100 by 5, and over here to be 10. The diameter and the thickness will be 0.5. Okay, add. Then I want another one which will be 75 by 3. Over here it will be 7.5, and over here it will be 0.3. Okay, 75 millimeters by 3 millimeters of thickness. Add. Now let me close this. Let me go to bars. Pick this section, the first one, the tubular 100 by 5, and I want to pick the point 0, 0, 0 over here in the graphical viewer. You may see the coordinates changing right now over here, but you can also check these coordinates also down here. Okay, as you may see now, both ones are changing. Okay, now let me pick the point 0, 0, 0 over here, and I'm going to press any digit key on the keyboard, and this will show the display the point dialog box. I forget one thing. I need to turn on the drag feature. Okay, 0, 0, 0 over here. Now I'm going to press 1, going to press the backspace, and I want the beginning node is defined as 0, 0, 0, and I want the next node up 3 meters. So I'm going to press the up arrow and press 3. Okay, now I want to go to the right, also 3 meters. So I'm going to press the right arrow and press 3 meters. Okay, you may see the coordinates in the reference point changing. Now I want to go down 3 meters, so I'm going to press the down arrow, 3, okay. And now I want to go to the left, also 3 meters. And this will be our box. I'm going just to press enter. You may see that we have already defined our box over here, our tubular box, okay. Now I want to go back to that plane. We go to 2D, this plane over here, okay. To close this. Now I am going to bars once again. Select the tubular 75 by 3. The drag is turned off, and now I'm going to the beginning field and select the coordinate 0, 0, 0. I guess it's this one, okay. And I will go to up here. And now select 0, 0, 3 and go down here, okay. There we go. Over here, close everything. Now I'm going to the view menu, projection, 3D, X, Y, and Z, and this will show you an axonometric view of the structure. Now I'm going once again to this icon over here, and I'm going to select this cross section. Okay, now I'm going to close. Press Ctrl A to select everything, and I'm going to edit menu, edit, move or copy. I'm going to enter the coordinates 0, 2.5 and 0. The number of repetitions will be 3, and I want the drag fixture turned on. Okay, I'm going to execute, and now I'm going to close. You may see what the drag fixture has done. I copied this square, okay, 2.5 meters over here 3 times. As you may see, the drag feature assigned these sections, these elements in red. If I didn't have the drag feature turned on, these bars wouldn't be here, okay? And the section that these bars have is the last section that I have picked over here in the sections, which is this one here, okay? It is this one over here, the 100 by 5, okay? Now we need to go to the view menu, projection XY. Over here, I'm going to select the supports icon. I want the pinned supports. Okay. Going to the current selection, now I'm going to pick this node, and also this node, and this node. Nothing else, okay? I'm going to press apply. Close. I'm going to press this button to see the isometric view. As you may see, I went to this plane over here, okay, on the view menu, projection X and Y, and this is over here. You may see the height that I am in, height 0, 0, okay, very good. Let me switch to an axonometric view of the structure, okay. Now let me go to loads. I'm going to press the add button, and this will define the load case with the nature self-weight, as you may see down here, and this load is always the self-weight applied to the whole structure. The first load case defined is always the self-weight. Robot structure analysis does this automatically, and this is a courtesy. He gives you this load case as a courtesy, okay? Now I'm going to press this symbol over here. This will show me a box, a view box, and I'm going to press 2D. I'm going to enter 3, pressing enter, and this jumps me to a height of 3 in the XY plane, but on a Z equals to 3, a height 3. I'm going to the loads menu, load definition, self-weight and mass, and I'm going to pick the added masses nodes over here. I'm going to give it these values, 100, 100, 100 kilograms. It's equivalent to 1 kilonewton. Okay, and this will define nodal masses whose weight is 100 kilograms for translational degrees of freedom. Okay, if I want rotational degrees of freedom, I would define it over here, and I want to apply to all cases. Okay, the masses will participate in all the load cases. I'm going to add, and I'm going to switch to the graphical viewer, and I'm going to select all the nodes presented over here. Apply. Now I'm going to close. As you may see, there we go. translational degrees of freedom. If I show this, these are just masses, so you don't get the value. You need to run a modal analysis or a dynamical analysis to see how this turns to forces. Okay, so now I guess I have spent all my time. In the next part we will start from this point. Okay, so thank you very much.